Let's get back to work.
So how does a breadboard work? If you were to open it up and look inside, you would see many horizontal rows of metal strips on the underside of the breadboard. On top of these metal rows are small clips. These clips hold a conductor or the leg of a component firmly in place on the breadboard. Once inserted, the component will be electrically connected to everything else placed in that row. This is because the metal rows are conductive and allow current to flow from any point in that strip. Here is a photo of a modern breadboard. The red line is the positive supply rail. The blue line is the negative supply rail. There is one of each of these lines on both sides of the board. There are sets of holes between the supply rails. Each set has 5 holes that are connected vertically to each other. These power rails can be extended by applying a link between each set of holes. The letters A, B, C, D, and E represent 5 holes and are connected to each other horizontally. These holes are used to connect components according to the requirements of the circuit. The same applies to F, G, H, I, and J. The center ridge separates each group of 5 holes and is used to connect integrated circuits.
In a previous video, we looked at how a breadboard is constructed, we looked at underneath and how the various input points are connected. In this exercise, we are now going to do an actual demonstration to see how this is done. To reiterate, this is my positive supply rail that we're going to be using. This is my negative supply rail that we'll be using. We'll use a 9-volt battery to power up this particular circuit. In this circuit here, I want to illuminate this LED. LED stands for light emitting diode. Now, a light emitting diode, if you look carefully, it has a long lead and a short lead. The long lead is called the anode, the short lead is called the cathode. It is the anode that always has a positive potential, and the cathode has a negative potential for this light to illuminate. However, this LED can only work with about 2, 2.4, 2.1, 2.3, depending on the color. The color of the LED will determine what voltage is required. We will talk about that in a later video. For now, we want to see how is it that we use the breadboard to connect these components. I need to use a resistor to reduce the current so that I don't damage my LED. It's good practice when you are using LEDs or transistors or anything of that sort to try and keep it uniform in the way it is positioned. For example, if I want to use an LED, I prefer to use the anode, if it's possible, always facing the top. So if I do have a problem and I'm doing fault finding, I know without having to pull it out and check, I know that for the most part my LEDs will have the anode facing in one particular direction. So I'm going to do that. I said we could use any one of these 5 holes to connect stuff. So I'm going to, now please don't do this, because now you're going to be short circuiting the LED, because you are now joining the both anode and cathode. So that's not how it should be done. This is a common error that people make, students especially, because they're still learning. This is what you need to be conscious of. I'm going to put my LED, try and put it in the way the manufacturer designed it so you don't stretch the contact pins, because what actually invariably happens is you damage it on the inside and you may not realize it, but this would be not working. So I'm going to put that in there, and as you can see, I'm just going to use this conductor to help us. There's 5 holes, 1, 2, 3, 4, and my anode. Here's another one, 1, 2, 3, 4, and my cathode. They are not touching each other. I need to insert a resistor or join a resistor, if you may, to the anode. I could use that entry point that one, or that one. Why? Because all 5 holes are connected to each other. All right, so I could choose any one. We'll just try that one, and I need to take it elsewhere, not to the cathode. I could take it to any bank of 5 because I don't want that to be connected to any other part of the LED. So just have a look. Always double check your work. Is my cathode or my anode connected to the resistor? It's the anode, as we discussed. If you look carefully, I've got my 5 holes here. My anode is connected to my resistor, and my resistor then goes into a different area. I want to power this up now. So I need a negative to be connected to my resistor. Where will I get that from? I'll get that from any of these entry points as we discussed before. I could go right down here and it will still work. And where do I want to connect it to? To my resistor. I could do that, or there. I could use any one of these because we know now that these 5 entry points are connected to each other. That is why I like to reiterate that it's important, absolutely important, that the student gets to know this board like the back of his hand, because everything that he's going to do, whether it's going to be resistors in series, parallel, doing calculations, joining things together, this will be the most appropriate medium rather than trying to hold it by your hand and twisting things together and using crocodile clips unnecessarily, etc. Yes, you'll see that I've got positive going there through my resistor to my anode, which is correct, and then I need a negative which is related to my cathode, and I'll take it from there. I could take it from anywhere, it doesn't really matter. I'll take it from there. If I fire this up now, the LED should come on. Okay. If I take my red, I could go and put this directly into the supply rail like so, and I could go and put into the negative supply rail just to prove a point, and there you go, it's working. If I took this out and put it there, it's working. If I took my supply out and put it here, it's working. So what have we proven? That this entire row of entry points are all interconnected, the red line, and this blue line, which we are using for the negative supply rail, are all interconnected from the first entry point right up to the last entry point. I can go anywhere I like and it's going to work. So as you can see, this is a very, very convenient way of connecting components together. If you had made a mistake and you put the LED the wrong way, or if you had made a mistake and put the resistor in the wrong entry point, it's so easy just to remove it, turn it around, put it back, and you'll be on your way again. So the breadboard is a very, very useful piece of equipment that students need to learn like the back of the hand, because this is going to help them in all the work they're going to be doing from level 2 right up to level 4.
Build a simple circuit with a breadboard, battery, resistor, and LED. Let's now do a short project where we will build a simple circuit that consists of a 330 ohm resistor, LED, and a 9-volt battery using a breadboard. Your facilitator will now pause the video and hand out the components you will need to do this activity. Refer to your workbook for the detailed instructions to this activity. Here is an example of what your completed project should look like. If the LED does not light up, ensure that the anode long lead is connected to the positive side of the battery through the 330 ohm resistor and the cathode is connected to the negative side. Remember that breadboards are so versatile that they can be used in a variety of ways. The same circuit could be connected like this.
End of the video. We'll be right back.